Hello everyone, welcome to my YouTube channel. My name is Hardeep and you are on the Kubernetes show. We are continuing our work on CKA Certified Kubernetes Administrator exam. Today I'd like to continue with this section that we couldn't complete last time. So link 2 and 3, they are open here. We will talk about these, and this was another section that I couldn't cover during my last video. Why do we need config map? First of all, config maps are needed if you want to store some configuration which is not inside your container. Basically, for example, let's say you have a web server. You don't want to put your uh, configuration file inside the container. Why? Because most of the times you want to tweak those configuration files on the runtime, or let's say you change the version, you updated the container, or let's say you are running Apache version 1, you went to version 2 or something like that, right? You want to make changes to the configuration, so segregating them makes more sense. So Kubernetes provides us with the two constructs. One is config maps, another is secrets. Difference between these two: config maps store data which is non-confidential. Okay, it is stored in key value pairs. Non-confidential means your data doesn't need to be something of secure nature. It can be generic data. For example, when I say secure nature, your password, your private key, that is kind of a secure nature, right? That falls into the category of secrets. So these config maps get injected into pods. You can kind of inject them in your pods as environment variables. You can pass kind of command line argument. You can mount them as files or volumes within your container. So there are different ways of consuming the config maps, right? So I was saying decoupling configuration from container image, and it is not designed to hold a large chunk of data, right? So if you want to store a large chunk of data, possibly you are not doing the right thing, and config map is not the right place to store this data. Maybe you store it somewhere where your init container can download and then start, right? Not in the config map. So it cannot exceed 1 MB of size, right? If you need to store larger than this, consider kind of storing it on a file system and mounting that volume and all that, right? So that's the idea. How does it look like? It looks very simple, similar structure of Kubernetes kind of file or manifest, right? It is a kind of config map. You give it a name. These are some of the required fields. Almost all Kubernetes components need these four lines, right? So you define API version, you define what type of item you are configuring, then metadata, and then the name. After this, there could be different options. For example, for a pod, you could have spec, uh, and here for config map, you have data. So what you are defining is database host name and log level debug, right? So let's say you are trying to run a database, you don't want to store the name of the database where it will listen, and what is the logging level, right? That is the idea why you store this data inside a config map. And how do you use the config map? You can use it, as I was saying, you can mount it, or you can use it as environment variables. How do you use it as environment variable? When you create a pod, inside the pod, inside container, you can use env parameter, right? So you are defining what is the name of the variable, right? Then it where the value is coming from for this. When you define a variable, you are saying this variable will come from a config map, and this is the name of the config map and what value will come from the config map, right? So you are also calling another variable. So you see this hyphen, And this hyphen, this tells you these are two things we are separately calling, right? Same similar story, value from config map and a name. And what is this is the name of the config map right here. And then we are calling a key from that name. So inside this name, inside this config map, there are two keys. One is database host, another is log level. One key we are calling here, and this is what that key is. And similarly, second key is getting called here, right? Key value log level, right? You can play with it in your environment, or there are some live environments where you can go and run these commands. During the exam, you should be able to do it on the fly, right? You don't have time. You should be able to kind of format your YAML file very quickly. You should not be wasting time looking for how to write it. So, uh, I would recommend using imperative commands, using kubectl create cm. Cm is short form for config map. Kubectl create cm, and then you can define, right? So I got this third one. So if you look at this one, it has some commands that I was just talking about, right? Create config map, or you can say cm, right? And name of the config map, and then you are saying from literal. Basically, whatever you are specifying from that it should do. There are options like from file, from literal. So you are saying this is the key you are defining, and this is the value inside that. Then there is another one, then audience is equal to Kubernetes. This is key, this is value. You see there is a double equal to in between. This is key, and this is a value getting assigned to that key, right? And how do you use it? You can see here, how am I calling it from? You can use this env from. This is one way of doing it, right? You are directly calling using env from, right? And you gave the reference, and you are directly kind of using it. This was another way of doing it using env, right? Here you are saying value from, and in this case we were saying env from, right? That's the only difference. But again, you don't need to remember all this. You can always run kubectl explain pod and then spec dot containers, and then, for example, env from, right? It'll tell you what all options you can write with it. What's the difference between config map and secrets? If config maps were for non-confidential data, right, versus secret, these are for sensitive data like password, token, keys, right? Similar to config map, they are designed for confidentiality. Again, they are similar, but this is kind of more focused on confidentiality versus config map data, which is generic data. You can kind of make it available to users to read, versus this data which is sensitive, you don't want them to see, right? Can be mounted as volume exposed through the environment variables. Similar story here. It is almost similar to config maps, but this data is kind of sensitive, right? Should be encrypted at rest, and you should think about using RBAC controls to limit access, right? So always keep these things in mind. By default, when you create a secret in Kubernetes, it is base 64 encoded. When I say base 64 encoded, that means your data is not actually encrypted. It is just stored as it is. For example, here I have shown, right? This is value for this one. Base 64 encoded my user is this thing, right? So if I want to show you what it means, here is what I had. So let's say this one, right? This is my user. So this ending with lcg double equal to, right? I'm doing base 64 hyphen d decode, right? So you can see lcg double, and that comes to my user, right? So this value is not actually encrypted, right? So the next one, you can see it says my password, and you can see the password as my password in clear text, right? So uh, your secrets by default are not encrypted, they are just encoded in base64 format. So keep that in mind. If you are deploying your own Kubernetes environment, you will have to configure encryption in your API config, uh, that so that it can go and encrypt your secrets in in your HCD database, right? All right. Next one is, that's why I have mentioned here, for true security, consider using HashiCorp Vault or AWS Secret Manager. Then next is similar story. It is limited to 1 GB size, discourage creation of very large secret, right? Because it could exhaust API server and kubelet memory, right? Uh, Again, similar story. You should not create too many of these, right? There are ways to control it using quotas and limits. You can kind of limit how many secrets one can create and all that. Then uh, y- you cannot use config map or secret with static pods. When I say static pods, it is, for example, in your master node, you have etc Kubernetes manifest directory, and there are files that are monitored by kubelet, and kubelet starts those pods, right? Those are called static pods, right? So that is why I have mentioned static pods are directly managed by kubelet daemon, and they are specific to node, and API server is not observing them, because those pods generally are the ones that start even API server too, right? So you cannot use config map and secrets with those two. Just keep that in mind. Nothing of it will come in exam. They don't ask you to configure this in the exam, but still you need to know when you are doing this for in real world environment. You need to know this, right? Depending on how you create your secrets, some of them can be propagated automatically, right? For example, secrets used as environment variable are not automatically updated in running pods. If secret is updated, new value will not be reflected, right? So what is the solution? Why should I keep my configuration file or even secret uh, separate, right? If it is not happening on the fly. Other way was using as volumes, right? See, kubelet checks for mounted secret volume for updates, and it is eventually consistent. But that also means that if you have mounted a secret as a volume, that can be changed on the fly. You don't need to stop your pod, start it again. But if it is an environment variable, it requires a kind of restart of your pod, right? And Kubernetes let you mark specific secret and config maps as immutable. Basically, you are not allowed to make changes to data, right? You can control all this using config, RBAC, and so basically idea is you don't want anyone to accidentally update or delete, or avoid accidental changes. That's the idea, right? So yeah, how do you define secret? It looks exactly same, right? API version be one kind. Earlier we saw config map, here it is secret, metadata, then a name, right? And then after that it tells you what type of secret it is. There are different types of secret. There are TLS type of secret. There is secret from literal, then from file. You can do all that, right? Um, how do you use it in a pod? Similar story. Environment, secret name, instead of a reference which we were seeing here, value from config map ref. Here it is value from secret key ref. That's the only difference, right? So what, this is the name of your uh, secret, and this is the key inside the secret. That's one key, right? Then you are calling the second secret, and name of the secret and name of the key, which is password here. Of course, during the exam you'll have to mm, again use imperative commands. You need to know how to create secrets, how to do them on the fly, right? And for that, I think I had some commands here. Yes. Yeah, the this is the third file, and this is second file. So if you go on this one, it says link 2, link 3. So link 3 has some commands that show you how to do it. Again, you don't need to run this command to create everything. You can run this command and say hyphen hyphen dry run hyphen o YAML. It'll print the YAML file and you can make modifications accordingly if you want to, right? If you are told to create a YAML file, for example, they don't say that in exam. They'll say in a particular namespace you go create this particular secret with this particular value and create a pod, mount it on a particular location, or make it available as a environment variable. Exactly similar question will be for config map too, right? So it's very easy to get confused with these. Spend time looking into kubernetes.io documentation, but if you kind of know how to run these commands imperatively, very easy to uh, kind of score these questions, right? Another tip: when you are giving your exam, sometimes you really want to kind of go and see, because main problem with the exam and the references on kubernetes.io, if I show you the hold on, kubernetes.io. So if I go here and show you right, so let's say I went to deployment, it shows some details about deployment. But when I say, let's say, config map, right? So if I say config map, main problem that you will face during the exam is config map details are shown correctly, but the usage is shown for a pod, right? But during the exam, they don't ask you to do it for a pod. They will say, do it for a deployment. Now, one way of doing this could be you go and fit this thing under the particular deployment and kind of do tabs to adjust the kind of tab spacing, right? Because YAML has problems with spacing and it need the proper structure, right? So one way could be you doing it manually. Another way could be looking at existing deployments. Where would you find existing deployments, right? Every uh, exam environment that they provide you, or they say, before you run any command, they'll say kubectl change context, right? You are set context or something, right? You are using a context, you are using a cluster. In every cluster there is a namespace called kube system. In kube system there are definitely running some pods. Most of those pods are already using config maps. Most of those pods are already using secrets, so you can take reference from them, right? So you don't need to remember, you don't need to get into kubernetes.io website. You can, within your exam environment itself, look at the configuration of another deployment and adjust the properties based on the question, right? Basically you do kubectl hyphen n kube system get deployment or something, name of the deployment, for example. you know you can look at kube dns maybe, right? For example, right? So for dns, it'll show you possibly some config map references, some secrets too. Use that, modify it, fit it to your uh, exam question needs, right? That should be able to kind of help you to pass that particular question, during the exam. But otherwise, uh, what I was saying earlier was, right, all the examples shown on Kubernetes website, most of them are shown for pod, and during exam you are asked to do it for a deployment. And the difference is, here it says deployment, your pod fits here. Basically, your pod comes 1 2 3 4, right? At least 4 level down it goes, versus spec starts from the beginning. Either you can copy this and paste, and in front of all these lines you add 4 spaces, then it will be fine. Or you copy from another one, right, and use it from there. That could be one way of kind of handling it, right? Anyways, that was just a tip for you. Next is manifest management and templating tools. I don't believe they're going to ask you to do something with it at a large scale during the exam, but if they do, all you need to understand is how does all this work. uh, you know so customize is native overlay management. When I say overlay management, it the way it works is, for example, you have all your deployments. For example, in this case, the directory structure is, you have a base and you have a directory called overlays. Inside that overlays directory, you have your different environments, right? So you have one deployment. Let's say you created one deployment. Let's say you want to deploy a database, right? Forget about this one for now, right? uh, so you want to deploy a database, and in your dev environment you want to have every deployment with a when you create a deployment, it should say uh, deployment hyphen dev. If it is dev environment, if it is production environment, you want to say deployment hyphen prod. Should happen automatically. You should not be required to maintain multiple files for it, right? So that was the idea behind it. So how do you do it? You do it with the help of this customization.yaml file. So in this customization.yaml file, you are listing the resources that customize should change for you on the fly. So for example, I have services also. If you don't include in this file, like inside base customization.yaml, this is the content written. But if you don't include the secrets, it'll look at only this resource. No matter you have 100 files under base, it won't look at them. It'll look at what you have specified here in resources, right? Now, inside every directory, like, there is one base, another is overlay directory, right? As I was saying, there is a dev and prod environment. So for example, in dev environment, there is a customization.yaml overlay patches for kind of different resources, right? You can write a file, and that file could be deployment patch.yaml. Oh yeah, one thing, this patch strategic merge is getting deprecated. There are two types of patches available. I'll have to recommend you to look at the customization documentation, right? So this is getting deprecated in version 5 of customization. Okay, but it is very similar to this. For example, for now, ignore this, right? As you'll have a file like this, which will have customization, and it will have something like these, right? So here we are saying, in our dev environment, for example, if we had this deployment patch.yaml inside this overlays dev directory, it says you need to have only one replica. But in production you could have five, right? So it'll run 5 db apps in production. If it is for dev, it'll run one. Whenever you want to apply with customization, you use hyphen k option, and you say overlay uh, and slash and name of the directory. So we have this overlays and dev directory and prod directory, right? Inside that we have only customization.yaml file, and that file contains something like this. During the exam, they might ask you that, okay, you have a customization file, how would you deploy it? That is all I know. I don't believe they're going to ask you to write it from scratch, but if you need to, it is here. You can go and search for customize, right? And you'll be able to kind of file, read it, and use details from here, right? But if you run command like this, qctl customize dot, it basically shows the values that are rendered. Okay, so for example, in this one, what it is doing is it is creating a file named application.properties, and inside that it is writing only one line. It says foo is equal to bar. This is the only line that we have in this file. Okay, next it is creating a file customization.yaml. Inside that file, config map generator, config map 1 files, and it adds this line application properties. So now if you see, when this guy runs kubectl customize dot slash, you can see the output. How does it look? It shows the data, it shows the application properties, and it says it is basically piping and showing everything, because here we are putting it as a file under it. So it is showing the content of that file, right? How did it happen? With the help of this config map generator. That's how it is coming as config map. And this is how it will end up showing on your screen, right? So don't worry about it whether this data is written above or below. All it matters is this API version data. It should start from the beginning. This has some spaces, this has some spaces, right? So that is what matters. It doesn't matter that first line should be API, second should be kind, and third metadata. No, that kind of structure doesn't matter. Only the spacing is what matters, right? Okay, but overall what you will see is API v1 kind, metadata, and finally data, and you'll see data like this, right? That is what it did. We did not specify this uh, inside this file or inside this file, right? How did it come to life? From here, from here. And we said was files, and it should get the content from that, and you can see how it is getting the content, right? Similar story for .env file, and he is doing foo is equal to bar, and config map generator envs, and then you can see it is just specifying a hidden file .env, right? And you can see how does it show up inside your container. This is what shows up inside the container. This foo bar shows up under data as foo bar because we defined it here in envs, and this is all rendered with the help of this customize, right? So whenever you are deploying changes, you deploy with the kubectl apply. If you just want to see, you say kubectl customize dot, and it will show you on screen. Customize is a overlay management tool. That means you are creating these overlay files, you are defining some values in them, and customization is able to go and modify your either deployment or service, whatever you define in base customization.yaml file. On the fly, it's making changes on the fly. Okay, that is customize. But Helm is bit more powerful. It's a package manager. So when I say package manager, it is packaging everything that you need to run a particular pod or deployment, right? So it uses Go templating language. You can see here how it is defining the format, and you the way it works is you define something called values.yaml, and when you deploy, you are doing helm install hello, and you are saying values.yaml. So you can have default values for it. On the top of that, you can say you want to override some values, so you use values.yaml, right? Again, I have given two links here that are focused on both of these things. right? Customize as well as on Helm, right? So if you go here, you can see how it shows. uh, you don't really need to understand everything, but this is very nice kind of hands-on. mm, it walks you through how to deploy, customize, what it does, right? It's deploying, customize, read through it, how it is kind of deploying different manifests. And then finally, after you are kind of done with these things, right, you will notice that there it is also deploying, it is making changes on the fly. For example, here it says customize build, right? On the fly it is making changes. See, every change is happening in customize.yaml file. I did not create a, I don't want to kind of steal the thunder of this. I want you to go and do some hands on following this. Try to understand what it is. If you have questions, let me know. This was customized, right? Similar story here. This is Helm. How to install Helm, how to use it, search, pull. I believe this is a good resource. In exam, they will not be asking you to kind of write a Helm chart. They'll ask you to possibly deploy a Helm chart, update a deployment, or make some changes. How do you do that? How do you see existing deployments? It all is covered in this one. Again, these are not my resources, these are third party, and you know I'm trying to provide all the credits to the owners, but I don't want to reinvent the wheel again. So there are nice tools available on these two. I would say you go and play with these, run some commands, and get some hands-on experience with it. Today's main topic during exam, two questions that you will definitely get. There is a possibility that it might come multiple times. One will be on your config maps, creating config map, mounting them as a volume or as a environment variable. You'll definitely see one question from this. Similarly, there will be another question from on secrets too, either mounting it as a volume or bringing it as environment variable, right? So use these two files, link 2 and 3, and learn how you can do it imperatively on the fly, and play with some parts. And let me know if you have any questions, or you like me to go deeper or run commands and show you how to do it, right? With that, I'll stop. I'll see you during next week. Take care. Goodbye.